Specific heat capacity. Q equals mc delta theta. That's the Greek letter theta. Sometimes you'll see it as written as delta T, like big T. It just means change in temperature. Delta, the triangle, means change in, and then theta will be temperature for Edexcel OCR, and then AQA use T. It just means the change in temperature. It's fine. So Q is the energy, M is the mass, C is the specific heat capacity, which is what this video is on, and delta theta or delta T is the change in temperature. Okay, and specific heat capacity, we talked about specific latent heat last time. Specific heat capacity is a little bit different. It's the amount of energy that's required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Okay, and this formula is one that you might use in method mark questions. You might get a 6 mark question on this, a 5 mark question on this. You might have to rearrange for specific heat capacity, in which case you would just divide through by mass and the change in temperature. So pretty simple. But instead of just talking at you like this, that's not really very helpful. I will just let you watch the tutorial video, and it will kind of explain everything that you need to know.
Okay, so let's discuss specific heat capacity in a bit more detail, and let's see how we can actually integrate it into some calculations. So the first part of our problem asks us to define specific heat capacity, okay, and the definition is just something you need to know, and it's the amount of energy that is needed to raise 1 kilogram of a substance by 1 degree Celsius, okay? So it's the amount of energy that's needed to raise a kilogram of a substance by 1 degree Celsius. And the equation for specific heat capacity is Q is equal to mc delta T, okay? Where Q is the energy that is required, okay? That's the energy input, right? And that is measured in joules. Where M is mass, which is measured in kilograms. Where C is specific heat capacity, which is measured in joules per kilogram per degrees Celsius, and temperature, this is delta. Delta means change in, okay? So that is effectively your change in temperature, okay? And that's measured in degrees Celsius, okay? So with this equation, I'm sure that we can figure out this question. And the question is, a student heats 300 grams of water from 30 degrees to 75 degrees, which means that our change in temperature is going to be our final temperature minus our initial temperature, which is going to be 45 degrees Celsius. And it says that we need to calculate the amount of energy that was required to cause this temperature change, right? And obviously we need specific heat capacity. Now, every substance has a different specific heat capacity, okay? Because a different amount of energy is needed to raise 1 kilogram of that particular substance by 1 degrees, okay? You can imagine it probably takes less energy to heat up a kilogram of metal because it's a fantastic conductor than it does to heat up a kilogram of plastic because it's a fantastic insulator, okay? So each substance has a specific heat capacity, okay? And the specific heat capacity of water is 4200 joules per kilo per degree. So using this information, surely we can find out Q, right? And the first thing that we need to do before we start substituting our values in is to convert from grams to kilograms. We divide by 1,000, we get 0.3 kilograms of water. And then it becomes as simple as just substituting our values, okay? So we will say that Q is equal to 0.3 times 4200 times 45. And then once you've got that value, plug that into the calculator and we get, so I'm doing it with you guys, we get 56,700 joules. And I would personally be putting that in kilojoules, yeah? Divide by 1,000 to get to kilojoules, okay? And that is how we can use our knowledge of specific heat capacity to calculate the energy that is needed to change the temperature of a substance.
Okay, so hopefully that was helpful, and hopefully you now understand specific heat capacity a bit better and how to apply the equation. Yeah, so just the best way to practice is to really just do those questions and to get a flow for rearranging the equation. As always, please like and subscribe, guys. It really helps us grow the channel and get more quantum content to you guys. But in the meantime, check out our other videos, and I'll see you next time. Okay, see you, bye.